In this chapter and in the coming lectures, we are going to talk about subqueries. So first of all, what are subqueries? A subquery is a standard SQL statement or query contained in another SQL query. It is always enclosed within parentheses. So for example, this is a typical subquery. We would like to select the name from the city database table where the ID of the given city is equals to another query. So the query is within parentheses, as you can see, and we select the maximum ID from the city. So basically, what's going to be the result? The ID is going to be the ID of the last item in the database, and then we select the name from the city where the ID is equals to the ID of the last city. So basically, this subquery is going to return with the name of the last city in the database table. So there are two parts. We have the outer SQL query or the statement that will produce the final result, and we have an inner query within parentheses, as you can see. So the ID is not equals to a predefined value, for example 212 or 78, but we are going to calculate the ID with the help of another SQL query. So this is the subquery itself that will produce the sub-result. The sub-result in this case is going to be the value for the ID, and if we know the value for the ID, then of course we can execute the outer SQL query in order to get the final result. Okay, so as you can see, a subquery is a given query within another query. So we have an inner SQL query and an outer SQL query. There are two main types of subqueries, the so-called non-correlated subqueries, and there are the so-called correlated subqueries. So first of all, let's talk about non-correlated subqueries. Non-correlated subqueries are totally self-contained, which means that it doesn't reference anything from the containing statement. So with non-correlated subqueries, the inner query doesn't depend on the outer query. We have to select every single column, so we use the star from the city database table where the ID is not equals to a given value. So this less than and greater than operator is the not logical operator, and then we select the maximum out of the ID values from the city database table. So what's going to be the result? The result of this inner query is going to be a given value. So where the ID is not equals to the ID of the last city, we are going to select everything from the city database table. So this is how we can select every single item from the city database table except for the last one. So in this case, the subquery, so the inner query, is a so-called scalar subquery because it returns with a single row and single column. So for example, with a single integer. This is exactly what's happening here. Select the maximum of the IDs from the city database table. It is going to return with the ID associated with the last city in the database table. So it is a single value, a scalar value, hence the name scalar subquery. Of course, it may happen that the subquery is going to return with multiple items. So for example, if we want to do something like this, so what does it mean? That we would like to select everything from the city database table where the ID is not equals to Hungary. So basically, we would like to exclude the Hungarian cities from the result set. Then the intuition is that we can do something like this. But of course, it is not going to work fine because the subquery returns multiple rows. Basically, it is going to return the ID of the cities in Hungary. And of course, there may be multiple cities, so it is not going to work fine. But we can use the in and not in keywords. So if we use something like this, it is going to work fine. We select every column from the city database table where the ID is not in the result set, and we create a subquery. We select the IDs of the cities in Hungary. And basically, it may happen that there are multiple cities from Hungary, so we are going to exclude these cities from the result set. So it may happen that the subquery or the inner query returns with a single value. These are the scalar subqueries, and it may happen that the result of the subquery is a set of items. So there are multiple items, and in these cases we have to use the in and not in keywords. Okay, so that's all about non-correlated subqueries. We are going to take a look at concrete examples, and it's going to be clear that in this case the inner query doesn't depend on the outer query. What about correlated subqueries? Correlated subqueries are not self-contained in the sense that it does reference something from the containing statement. So with correlated subqueries, the inner query does depend on the outer query. They are not independent of each other. And this is why correlated subqueries are slower and they should be avoided if possible, because they are not executed once prior the execution of the containing statement. Correlated subqueries are executed once for each and every candidate row. So this is why we should avoid correlated subqueries, because the inner query is not independent of the outer query. So for example, if we want to select the country names where the number of cities is equals to 22, so as you can see we select the country.name from the country database table, where the select count star from city C, where C country code is equals to the country.code, it means that we would like to gather all the countries where the number of cities, so as you can see we count the number of cities is equals to 22. And of course this is a typical correlated subquery where the inner query is not independent of the outer query, and in these cases the subquery is not executed just once, but it is going to be executed multiple times, and this is why it is not that efficient. So we should avoid using correlated subqueries, and we will come to the conclusion that we can transform correlated subqueries into joining tables. By the way, it is true for every subquery, not just correlated subquery, but for non-correlated subqueries as well, that we can join tables instead, and sometimes it is a bit better solution because joining tables are much more efficient. In the next lectures we are going to take a look at a given example as far as correlated subqueries and non-correlated subqueries are concerned. Thanks for watching.
Hi, in the previous lecture we have been discussing the basics as far as subqueries are concerned. So in this lecture I would like to show you an example for the non-correlated subqueries, and we are just going to make a very simple query that, for example, I would like to select everything, so every single column from the city database table where the ID of that given city is not equal. If we would like to make sure that it is equal, we use the equal sign, we can use the less than, the greater than, and we have the not equal operator, and we just want to make a subquery. We would like to find, for example, the maximum as far as the IDs are concerned from the city database table. Okay, let's run it. And the result set is going to contain every row from the city database table except for the last one. As you can see, this is an example for the scalar subquery. This is what we have been discussing in a theoretical section, that it is non-correlated because the inner select has nothing to do with the outer select. So the inner query doesn't depend on the outer query. So it is totally self-contained. It is a scalar subquery because the returned result set has a single row and a single column, basically a single integer ID. Okay, so we have selected the maximum out of the IDs from the city database table, and then we are going to select everything from the city database table where the ID is not equal to the one we have selected with the subquery. So basically we have managed to exclude the ID with the maximum value from the result set. Okay, so this is how we use non-correlated scalar subquery. Thanks for watching. Hi, in the previous lecture we have been discussing how to construct a non-correlated scalar subquery, and it's not going to work in every case. For example, in this case, as you can see, we returned a scalar value, just a single integer ID. But what if this subquery returns a set of integers? For example, we would like to select everything except for the Hungarian cities. Okay, the naive approach would be to select the IDs from the city database table where the country code, so the country code is equal to HUN. What does it mean? It stands for Hungary. So basically, you may guess that it's going to work fine. We are going to select every single city where the ID is not equal to the Hungarian IDs. Okay, let's try to run it. There's going to be an exception. Okay, so first of all, by the way, let's try to run this query alone. I guess it's going to return the... Okay, as you can see, the integers, the IDs concerning Hungary. So basically the subquery itself is valid and the outer query is valid, as you can see. So the problem is that this subquery is going to return a result set and we have just a single ID. So we would like to compare a single value with a set of values. And of course, we can use the in operator in this case. So I would like to exclude, so not in the result set that's been returned with the subquery. So what does it mean? I would like to select everything from the city database table where the ID is not in the set returned by the subquery, and the subquery is going to return the IDs concerning Hungary. So let's try to run it. Okay, because we have to use something like this for strings. And as you can see, it's going to return everything except for Hungary. For example, just to be able to check it quite easily, let's exclude Afghanistan. So AFG. And if we run it, as you can see, AFG is not going to be in the result set. So we have managed to select every single city except for the cities located in Afghanistan. So this is how we make non-correlated but multiple row subqueries, and it's going to work just fine, as you can see. Thanks for watching. Hi, in the previous lectures we have been talking about non-correlated subqueries, and in this lecture we are going to talk about correlated subqueries. So for example, the problem we would like to solve is that we would like to find the given countries that contains exactly 22 cities. So let's get started. I would like to select the country table name of that given country as, for example, the country. Okay. Of course, I would like to select it from the country database table. And we just have to specify that where 22, because we are looking for 22 cities, so 22 is equal to a result of a subquery. So we just have to select and we just have to count from city. So we would like to select basically from the city database table, and I'm going to have the alias C, where the c.country code is equals to the country table dot code. Okay, let's reformat our SQL script, and as you can see, it is a correlated subquery because we are going to reference the country table code that we select in the outer SQL statement. And basically on every iteration we check whether that given value is equals to 22 or not. And the result should be, I guess, 3 countries. Okay, first of all we have some issues. And of course, because the country table is not specified, sorry for that, we have to use an alias. So the country database table will be called as country table. Let's try to rerun our SQL code, and as you can see, Morocco, Peru and Vietnam are the countries that has exactly 22 cities. So this is how we select countries with exactly 22 countries with the help of subqueries. And it's very important, in one of the coming lectures we are going to transform this given SQL query, and we are going to solve this problem with the help of joining tables. Why? Because it is very slow approach. So it's going to be a slow algorithm solving this problem with the help of subqueries. So that's why usually we use joins instead of subqueries, but this is what we are going to talk about in the next lecture. Thanks for watching.
in the previous lectures we have been talking about non-correlated subqueries and correlated subqueries, and in this lecture we are going to talk about the performance-related issues. So as far as non-correlated subqueries are concerned, they are working quite fine. So we have been talking about that the inner query runs on its own, so doesn't depend on the outer query, and this is why non-correlated subqueries are working quite fine. The inner query is executed before the outer query, and we can use it without any issues. As far as correlated subqueries are concerned, usually it is a good programming practice to avoid using correlated subqueries, because the inner query depends on the outer query, which means that the outer query is executed before the inner query multiple times. And this is why it is not that efficient, so we should use join instead. So we can come to the conclusion that subqueries and joining tables are interchangeable. So we could use join statements whenever we are using subqueries and vice versa. Usually combining tables with the join statement is a more efficient approach, and this is why we are going to talk about it in the next lecture. Thanks for watching.
Hi. In one of the previous lectures, we have been talking about how to select countries that has exactly 22 cities, and we have managed to solve this problem with the help of correlated subqueries. And in the previous lecture, I have told you that okay, we are able to transform a subquery into using joins. And this is what we are going to talk about. So this is how we solve the problem with the help of subqueries, and we are able to solve this problem with the help of joining the two tables, the city table and the country table, and we have to use the group by keyword. So I would like to select country table dot name. Then I'm going to use some alias, for example country. Then I would like to count the city table dot country code as the num of cities. Of course, we have to say that from the city database table as the city table, and then we have to join two tables. So I would like to join the country table as the country table. Of course, we have to specify that what's the relationship between the two tables. Of course, again, the city table dot country code is equal to the country table dot code. Okay. And then we just have to use the group by. We would like to group the results according to the country codes. So the city table dot country code, and we just have to specify that we should use where, but we are not able to use where, we have to use having. So having the number of cities is equals to 22, and I would like to make some ordering, so order by the number of cities in descending order. So let's try to reformat or SQL script, and I guess it's going to work just fine. We select the country table name as country, we count the city table country codes as number of cities from the city table as city table, joining country as country table, on city table country code is equal to the country table code, we group by according to the country codes, having number of cities is equal to 22. Okay, let's try to run it. Okay, and as you can see, the result set is the same as we have seen for subqueries: Vietnam, Peru, and Morocco. Okay, so this is how we transform a subquery into joining tables with the help of the join keyword. Thanks for watching.